Hello and welcome everyone. Thank you for joining us today for our webinar titled H2O.ai in the Cloud. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Vinod Iyengar is Vice President of Customer Success and Product at H2O.ai. He leads all product marketing efforts, new product development, and customer engagement. Vinod comes with over 10 years of marketing and data science experience in multiple startups. He was a founding employee for his previous startup, Active Hours, where he helped build the product and bootstrap the user acquisition with growth hacking. He has worked to grow the user base for companies from almost nothing to millions of customers. He's built models to score leads, reduce churn, increase conversion, prevent fraud, and many more use cases. Rafael Cos is a community and partner maker at H2O.ai. Prior to H2O.ai, he was a technical marketing and community director and a developer advocate at Hortonworks. He was also DataWorks Summit Program co-chair for the past 3 years. And prior to Hortonworks, he was a senior solutions architect and manager of IBM's worldwide big data enablement team. At IBM, he was responsible for the technical product enablement for big insights and streams. And previously, he had held several other positions in IBM where he worked on tools, XMLDB, FederateDB, and Object Relational DB. Now, before I hand it over to Vinod and Rafael, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Vinod.
Thank you, Patrick. Hello, everyone. Thank you all for joining us today. First of all, I really want to wish you all, hope everyone is safe at their homes. We are, of course, living in really interesting and really unusual circumstances here, but it's an opportunity for us to all continue to connect through the web and then, understand and help each other get through this crisis. So with that, I want to say welcome you all to this webinar today. So today's topic is essentially H2O.ai and the cloud, but more importantly, we want to just understand what does it take to use AI effectively, right, as an organization. And one of the design patterns that we've been seeing over the past many years, especially in the last few years, is that customers are moving more and more to the cloud, and then all the workloads, including machine learning and AI workloads, are moving there. And then that brings up a whole bunch of new interesting questions for us to answer, like how do you, which cloud vendor to pick, when do you move to the cloud, what data assets do you need to bring in there, what are best design practices there, and then understanding how do you do those things with kind of like a multi-cloud infrastructure if you need to, or how does hybrid work, and then the role of open source AI and all of these things. So we'll try to tackle, or at least touch upon a lot of these topics. And then as we're doing that, definitely feel free to post your questions. We'll definitely leave some time at the end to answer those questions. We do want to make this interactive. Okay. So to quickly introduce who we are H2O.ai. Our mission is democratizing AI. What that means by that is we want to be a trusted partner for our customers, bringing AI transformation to enterprises, helping them transform their businesses fundamentally by data science, machine learning, and AI. That's one of the big parts of what we are set out to do. Similarly, we also want to help the community, basically by open source efforts. We are a leading industry leader in providing cutting-edge open source tools for AI and ML. And we want to make sure that everyone is able to take advantage of this, whether it's researchers, academics, people working even in industries, right, be able to take the advantage of the best of breed open source tools for machine learning and AI. And finally, there is a mission to do good as well. We want to make sure that the benefits of AI and machine learning are available for nonprofits and other sort of ventures as well. So we work with the part of the AI for Good initiative. We work with folks like Wildbook, work with hospitals, we work with nonprofits, researchers, and academics to help take advantage of machine learning and AI for a lot of social good. So as a company, right, we are about 220 folks currently. We're founded in Silicon Valley. We are a venture-backed company. We have raised over $147 million. And our last round was a Series D late last year. Our investors include a whole bunch of who's who, right, from Goldman Sachs and to Wells Fargo, Ping An, out of China, NVIDIA, Nexus Ventures. We have a whole bunch of platforms. We'll look at some of those in a little bit more detail, but we are very popularly known for our H2O open source platform, which are also called as H2O Core or H2O 3. That's been out there for nearly 7 years now, and it's very widely used. When we were counting, over 20,000 companies were using it globally, and over 200,000 data scientists at any point of time are using the H2O open source platform for machine learning. In addition, we have an automatic ML platform called Driverless AI and something called Q for business users. We'll get to those in a second. But we are really fundamentally a customer-driven company, right? So we work with a lot of companies across different verticals, from financial services to healthcare to marketing, retail, and we have a lot of expertise across the globe as well. We work with customers in North America, Europe, Asia, Latam, Africa as well. So a lot of different environments, different domains, verticals. And to support that customer base, we are, as a company, also very global. So we are, of course, headquartered in Mountain View, California, but we have offices in New York, London, Paris, Ottawa, Prague, Chennai, and Singapore. Our team is made up of course, some of the world's best data scientists, researchers, computer scientists, and experts. But one of the sort of things that people know about or knows for is our Kaggle Grandmaster SWAT team as well, right? So we have nearly 10% of the world's Grandmaster population. So there's only about about 150 odd Grandmasters in the whole world. In Kaggle. Kaggle is a data science portal where competitions are regularly held, right? And out of those, we have about 10% of them working for H2O. And as you can see, they're all over the globe, right? So we really want to hire the best talent wherever they are. And then the good thing for our customers is that they are available to solve their critical problems, available as experts to come in and chime wherever needed, or bring in the custom recipes or custom models which can be reused by our customers, right? So we are able to bring the best talent out there, apply their brain power to solve specific customer issues. Now, our journey, when we work with customers, essentially, this is what we do, right, on a regular basis. We are part of partners in that AI journey. We want to make sure that we help guide you in the process. We teach you, your domain scientists and experts. We teach them how to become better data scientists or become AI experts. We can bring in our Kaggle Grandmaster pool, our senior data science, expert data science pool as well, as basically consultants, right, to help you brainstorm, sometimes ideate, or even build models, do whatever it takes. We are able to bring in a lot of references. That's part of the empathy that we bring to the table. We have worked with hundreds of customers across the globe in multiple domains, industries. So we have a lot of learnings from all of these, some best practices. A lot of cases where we know what things didn't work. So we have like our past failures to guide us as well. So we can bring all of those learnings together to our customers to sort of help them shortcut or avoid the pitfalls if we can. And finally, we want to make sure that we are partners in your journey, in the sense that we want to help you build new business models, innovate with you, and find out what makes sense. And of course, we want to do this, really doing this on the cloud as well. So just some examples of what we have done with customers across the world, right? So we have digital marketing. We've helped customers become almost 700% more effective in the marketing campaigns just by using better models. We've helped save some of our insurance companies, customers over $20 million per year just by improving the underwriting models. We improved the fraud detection models of our customers by nearly 2x, doubling the identification rate, right? Supply chain, and then also things like debt scoring. We have helped reduce debt rate by nearly $10 million per month in some of our customers. One of the things we are really proud about is our work with the healthcare side. So, for example, one of the largest hospital chains in the country and the globe, we work with them to predict sepsis when patients are in the hospital, and we are able to reduce the sepsis rate by nearly 10%. In addition, we also done things like predict the flu season forecast. We also are part of the COVID crisis. We are working with them to help predict how many ICU beds are going to be required in every facility, how many, help with the supply chain of how many masks to order, how many things to order. So a lot of these cases across different domains built on a core set of platforms. So then I'm going to have Rafael jump in and just quickly go through our platforms and explain what we do.
Yeah, thanks, Vinod. So, we have, as Vinod mentioned, we have multiple sort of product lines. Historically, we started with an open source set of algorithms, so called H2O3. And this is our distributed machine learning engine. So it can run in a Hadoop environment, it can run in a Spark environment, it can run in a Kubernetes environment, and it can scale from a single machine into these large clusters, right? We also have sort of a complementary offering called Sparkling Water that allows you to integrate with Spark for data prep, and you're still using H2O3 for building models, right? Then we have our flagship automatic machine learning platform, Driverless AI, that kind of is focused on sort of automating some of the tedious tasks in building high quality models. And we'll kind of dive deeper into Driverless AI in this presentation. And then there's H2OQ, right? So H2OQ is our next generation tool for business analysts that allows them to kind of go from exploratory data analysis to classic descriptive analytics, and then kind of using AI to do BI to sort of discover new insights in the data. And so H2OQ is currently in beta at the moment, right? So these are our three platforms for AI and machine learning. Next slide, please. So as we look at how we can leverage H2O AI in the cloud, one of the key things that we need to start exploring is how do we manage these environments, right? And so with that, we have two additional tools, one H2O Steam and the other Enterprise Puddle, that can be leveraged to manage these AI platforms both on-prem and in the cloud and multi-cloud. Next slide. So as we look at these tools, right, H2O Steam allows us to provision, secure, and manage both H2O3 clusters and services, but also Driverless AI, right? And so if whether you're using H2O3 in on-prem cluster or in a cloud cluster like EMR or HD Insights in Azure, Steam facilitates the management and provisioning and the securing of that environment. And as we look at Enterprise Puddle, so Enterprise Puddle works on Azure, AWS, and GCP, and allows us to secure and manage H2O services in this environment. And H2 Puddle provides not only an interface for administrators to administer and secure this environment, but also makes it easier for data scientists to kind of work in a cloud environment. Because sometimes, yes, data scientists are these unicorns with multiple skills, but adding more skills around working within a cloud environment and maneuvering that, you want to make it easy for data scientists to kind of get access to data, start being able to run experiments, work with multiple algorithms, right? And that's what kind of Puddle does. And we'll see a demo of that as kind of go through. So next slide. Yeah, and so here's what a quick thing what it looks like. So cloud is accelerating the digital transformation, right? And as we're looking at accelerating that digital transformation, data and AI are fueling it, right? And so cloud is a key driver. But as you're driving that, what you're doing for AI and how you think about an AI architecture can make a huge difference in how you kind of go forward with that. So let me hand it back over to Vinod.
Thank you, Rafael. Yeah, so I think I just want to just flip back to the Gartner Cloud AI developer services, machine learning, like Magic Quadrant came out earlier this year. And this is a definition I thought was very interesting, right? So the way they start is a cloud AI services, basically allowing cloud-hosted models that allow development teams to leverage AI models via APIs or directly without requiring deep data science expertise. And that's a critical part, right? Helping bring the power of AI and machine learning to a whole bunch of new audiences, right? Like developers, data scientists, business users, without requiring coding or a lot of like expertise from data scientists, doing automation as much as possible, right? And then these services are often available via API access. This is all the critical part. So the output of those models need to be consumable by other cloud applications. So essentially having a really integrated story around how do you train the models and then deploy them very easily. And that's what we've been focused on over the last few years with our customers as they making the journey into migrating to the cloud, right? So let's kind of talk about, and this is, some of the slides we covered in the past, like from late last year, I've done a webinar with one of our cloud architects on sort of considerations in the cloud, and I want to bring up some of those sort of key points again because I think they're still very relevant, right? So obviously, one of the things that you want to think about is like as you're moving to the cloud, notion of using cloud-native applications and then all-in cloud strategy, right? So what I mean by that is, for every sort of platform, software, or tool you pick, there is of course a cloud-native alternative as well, right? So, and oftentimes the question comes to around should we use what we have from before, or should we use something cloud-native, right? And there's pros and cons to both, but obviously the things to remember are essentially, if you go completely 100% cloud, you essentially have a journey like, this is so this kind of think of it like 4 steps, right? If you're on-prem, you are fully on-prem, you're using cloud only to do burst applications, but then and then if you do hybrid, you are sort of using some part of it for the cloud, some part of it on-prem, mix and match, and then maybe going to single cloud versus going to multi-cloud strategy, right? So it's a little bit of a journey. But as you're doing that, you can think about what tooling to use and find out where you are in the journey, right? So where do you feel comfortable as a company, right? So if you are just starting out, maybe you are better off going to like a hybrid strategy where you don't completely do a lift and shift. So you take some of the data sets, some of the use cases or data sets which are more comfortable cloud. So for example, a lot of large banks and sort of healthcare companies, what they've done is they start up with like the marketing and sales use cases. So those data sets are often already sitting in things like Salesforce or market-owned cloud-native applications. So bringing them to the cloud is a little bit easier. So start with those, and then slowly start moving the other critical, more sensitive data, which might be like GDPR compliant or CCPA compliant, and you bring those later down the line. So thinking about where you are in the maturity cycle is important, and then use this as like a rubric to figure out where you want to sort of land, or where do you want to be in the next 12 to 18 months. And then, and maybe Rafael will chime in here, so one of the things you can think about is essentially, doing single cloud as a multi-cloud approach, or even like a hybrid cloud approach, right? So the reasons to do that are essentially, think about cloud lock-in is a real thing, right? So if you start using cloud-native applications, it gives you a lot of convenience, and maybe the time to getting started is lower, but you do have the notion of vendor lock-in. So you have one cloud lock-in, and then managing those costs becomes interesting, right? So having a multi-cloud strategy can improve reliability and availability, but also let you sort of distribute your risk across multiple clouds and multiple vendors, and then also being able to control your costs, right? Often there's a bidding war between the different public cloud vendors to find the most cheapest cost available. So you want the flexibility to be able to avail of those benefits. So how does this all fit within AI, right? If you think about this, and this is Gartner again, right? So they've been, one of the predictions is that the strategy comprising of multiple, infrastructure as service or PaaS providers will become common. I would say this is still a little optimistic. At this point, most of the customers we see are primarily single cloud only. But down the line, this could happen, and there are some positive sort of movements towards that. Like, so things like the rise of Kubernetes as a shared orchestration layer. So all the public clouds will have a really strong Kubernetes layer to orchestrate your workloads. And similarly, the availability of tool chains like ours, like H2O and other platforms across all the multiple clouds. So that allows you to essentially have a very, very consistent experience across each of the different clouds.
It's not just like going. And it's not just going the multi-cloud, right? It's also kind of like, as you're thinking about an architecture, what will create an architecture that will give you the flexibility if you're one cloud today, maybe tomorrow go to a different cloud if the price and the services are appropriate, without giving that flexibility to move quickly without having so much sort of inertia built into it, or that you're locked into one cloud vendor, right? So you not only want to think about the multi-cloud approach, but also kind of the flexibility in the cloud approach, right?
Yeah, definitely. And then that said, I think open source AIs or all freaking vendors like who are like strongly neutral or like a strong standalone companies basically, it's probably a useful strategy, right? So one of the things that our customers prefer us over, let's say, cloud locked-in provider is the ability to have a best-of-breed software that can work across multiple clouds or on-prem for that matter, right? Being able to take those workloads and run them consistently across different environments. Anything you want to add, Rafael?
No, I mean, I like, again, it's like, we think that it's important to kind of look at a vendor that give you the flexibility to work on whatever cloud and infrastructure that you're going with, right? So that as your IT infrastructure changes, have the ability to move your AI analytics with that infrastructure without being tied to it, right?
Thank you. So yeah, and I think in H2O, as we feel it's very strongly placed, and the validation comes from, you don't have to take our word. You can look at the Gartner MQs, for example. This year, we were featured for the first time in 2 different Magic Quadrants. On the left, you have the data science and machine learning MQ, which has just been there for about 4 or 5 years now, and we've been consistently placing there. So we were named a visionary. We had the strongest completeness of vision in the entire quadrant, and they ranked our strengths on as automation, explainability, and high-performance machine learning components. On the right, you have the Cloud AI for Developer Services MQ. This is a very brand new MQ that came out for the first time this year, and we were the only vendor to feature strongly, like only sort of like a non-cloud vendor to feature strongly in both platforms, right? So we did feature on both sides, and we were given really high points, again, for automation, ease of use, and explainability, and excellent customer support. So we know, and I think among the sort of non-cloud providers, we had the biggest ranking, and that again, going back to the previous slide, if you want to pick a neutral, good standalone company with solid best-of-breed software, H2O comes in pretty high at the top there. So when think about, again, value proposition of the cloud, right? I think what you have to think about is that, of course, CapEx versus OpEx, right? So you don't have to make upfront purchases in hardware or software. A lot of this can be pay as you go. Again, usage. There's of course ways to like cap the costs even on Prem, but cloud gives you the benefit, right? So you can really have a flexible schedule of payment and your costs. It also allows you to be scalable. So really, there's no limit on your data center size. Your data center can be almost near infinite scalable, right? And you can be available across the globe. So you can have services with very low latency across the globe. That's why a lot of the high-tech companies or like apps and services are completely built cloud first, because that gives them the flexibility to do this very nicely. Of course, you have access to the latest technology as well, right? So you can have the latest version of the software. Your upgrade cycles are much faster because with SaaS applications or even managed applications, you can update your environment. Your DevOps cost is much reduced, so you can keep constantly updating to the latest versions or latest things. You can try a lot more things very easily. So those are definitely all strong value propositions and big reasons why customers are migrating to the cloud and sort of taking the decision to move their on-prem workloads there. With that said, of course, and there is, of course, a whole bunch of reasons to stay on-prem. Like the reasons why customers, if you argue, could argue is, one is, of course, that the infrastructure is already paid for. If you already invested in your hardware, it's already there. There's no additional cost. And on the cloud side, even though your your OpEx might go up, but you will see, some of these instances can be pretty expensive, especially when you use GPUs and other high compute instances. So cost can be a concern. So knowing awareness of that is important. But on the flip side, there is also cost management not being important on-prem. Like in some cases, if security is more important than cost or convenience, then you are, if you really care about make sure that none of my data ever leaves, you don't want to be completely proof, secure, then a lot of customers choose to stay on-prem for those reasons. And of course, with that, there are things like the privacy regulations like GDPR, HIPAA, PCI, etc. For a lot of financial services, healthcare firms, navigating that in the cloud is a longer journey. So they are still early in the journey, so they would rather at this point take the safe choice by staying on-prem. And for that, all the public cloud vendors are making efforts to help move GDPR-sensitive data, HIPAA-compliant data, PCI data into the cloud, slowly but surely. So there's ways to achieve that in the right fashion. And of course, when you have constant loads, if you know that you have a long-running system that's going to be running on multiple GPUs 24/7, you can actually amortize the cost. You can buy the hardware and amortize the cost over the next few years, but also get a good discount when you buy it outright. So there's sort of reasons to think about this both sides. So let's look at what about the machine learning workloads or the AI workloads, right? So the considerations for those are essentially, if you think about data gravity is important, right? So you don't want to move your data back and forth. So whether you're cloud or on-prem, or even on cloud, whether you're in different regions, right? Ideally, you want your compute to run very close to the data. So bring your compute to the data, and that's very convenient to do in the cloud, right? So you can start, for example, an H2O instance in the region where your data is sitting, and then you can basically pull the data in there, and you have as low the latency as possible there, right? And still be able to do secure connections and pull the data and do the analysis. Similarly, you have the ability to use a lot of new frameworks. There is this notion of you can have the advantage of first to market. Because, for example, every time we put out a version of our software that goes up on public clouds in the marketplace within days. So if you want to upgrade to the latest version of H2O, it takes you less than 10 minutes to do so. And doing this on-prem would be a lot more longer process, right? So obviously you'll have to go through a big change management process and an installation process. And a lot of those things are add up over time, and that can be a big advantage too. And finally, there is of course the ability to use latest hardware, right? So if you're on-prem, typically your hardware cycle and your replacement cycle will be anywhere from 18 months to 24 months, sometimes even up to 3-4 years, right? Whereas on the cloud, you can just go to the latest instance. So for example, if there is a new version of a CPU that Intel launches, the new Skylake CPUs or the new latest Voltas, you can just go and ask for them, or even get TPUs, for example, right, on Google Cloud, right? It's very easy to start a trial or a POC on a new environment just to see if the performance benefit is worth it, right? And those are the benefits that that can be very valuable, especially in cutting edge or places where you're doing a lot of work that is high compute intense. So that I want to sort of look at some of the cloud architectures, reference architectures very quickly. So what have we done in the past with some of our customers, right? So this is an example of how you can run H2O on AWS. So this is H2O open source, but you can very easily think of Steam as well in a kind of similar format, right? So Steam, like Rafael mentioned earlier, is a DevOps management software, and you can essentially have Steam manage a cluster of H2O nodes running on EMR, for example. You can pull data from Snowflake, Redshift, or S3 to a JDBC connector or a native connector, and then run the analysis on the H2O cluster managed through Steam. So the users will always log in through Steam, provision the clusters, and then be able to access through Jupyter Notebook or Python or RStudio or H2O Flow, the H2O cluster itself to run the jobs. And all of this can be running in your VPC, so you never leave the AWS VPC. Right? So it's a very convenient way to get up and running and offer almost like a managed service for data science on AWS. And you can do something similar on GCP and Microsoft Azure as well. And this is the EMR example, of course, right? So, so the base H2O cluster, you have the EMR cluster, and again, managed by Steam. And then when it comes to deployment, you can do something similar, right? You can basically deploy your models in multiple ways. So you can do a one-click deploy to a Lambda function, or you can do a deployment. You can containerize it and then deploy into SageMaker, right? So essentially, you can take a model, package it into a container in ECR, and then deploy the model into SageMaker as a REST endpoint. So there's multiple ways to deploy models as well, and all of this can be fully automated to do that. This is a couple of examples of how we can do this. And very similarly, if you go to the Google Cloud side, we can do something similar, right? So instead of, they have something called as DataProc, which is a managed Hadoop cluster in Google Cloud. So you can use DataProc cluster to run H2O cluster or Sparkling Water cluster. Again, ingest data through the JDBC connector from BigQuery or from Google Cloud Storage, and then use Steam to manage the cluster, and then use H2O Flow or Python to log into the cluster, work on that, and then submit the jobs. All the workloads will be running on the cluster, and then the models can then be saved back into the cloud storage. From there, it can be deployed using cloud functions. You can use this to then apply your own authentication. For Steam will do authentication to LDAP or SAML or Active Directory, depending on your choices. Yeah, and then for deployment, you can also do things like Hive UDF. So you can take the model, the mojo you get, package it into a UDF, and then use that to do batch scoring back or in database scoring back into BigQuery or as a UDF, right? So multiple ways to deploy models and run this clusters as well. So that I want to hand it over to Rafael to talk about the Driverless AI software.
Thanks, Vinod. Can you go to the next slide? So Darla Theory is our flagship automatic machine learning platform with the focus to help make your company into an AI company, right? So Darla Theory leverages AI to do AI. So there's a genetic algorithm that works towards optimizing various algorithms to kind of produce the best model possible, right? And it does this to kind of help you get insights, but also kind of be able to generate explanations. And one of the unique capabilities of Driverless AI, not only is it this machine learning optimization platform, but it's an open and accessible machine learning optimization platform. And all the recipes that all the algorithms that it uses, it's using open source. And then we have, this open extensible platform that also provides additional recipes that kind of to improve optimization. And we have an open catalog where you can kind of discover even more of these. Next slide. Right, so the focus of Driverless AI is to help get answers faster, right? To help drive that, discovering of insights, the development of those algorithms to streamline that machine learning workflow, right? From that exploratory data analysis to, tuning and selecting your different algorithms, doing the model tuning, doing the explanation of the models, the documentation of the models, and then getting to a point where you can actually get ready to deploy, right? And how can we automate, having a deployment ready sort of artifact. And next slide, please. So this is, as you kind of look at the machine learning workflow, right, this is what a high-level architecture looks like of how that process kind of goes. Clearly you start with getting access to the data, And as we kind of look at the cloud, yes, we want access to data on-prem, but we also want to have all these various connectors to various cloud data sources, whether it's, the objects, various flavors of the object stores, S3 and such, or, databases in the cloud, such as Snowflake or BigQuery, right? And so we can quickly pull in the data, be able to identify, what is the target column, the label that we want to work with, go through sort of exploratory data analysis using automatic visualizations, right? And then we kind of get into this phase of optimizing the model, where we kind of select algorithms, what we're optimizing to, keep iterating on feature engineering as we kind of optimize the model. And one of the things that's, again, it's sort of interesting about Driverless AI, that it's an open and extensible sort of platform, right? So there's these built-in sort of feature engineering algorithms and tuning, scoring mechanisms, but you can also bring your own, right? So you can bring your own recipe to sort of augment the automation that's happening with driverless, right? And then once you've have this experiment that's run, you kind of want to explore the explanations and interpret the models that have been produced, right? So we automatically generate a whole series of metrics and dashboards around that. We want to kind of automatically generate documentation for the experiment. This is a 30 to 40 page report that gets automatically generated. And once you kind of look at that and you're ready to actually deploy, we also automatically generate a scoring pipeline, right? And I'll get a little bit more into this scoring pipeline in the next couple of slides. Next slide, please. Right, so as we look at that deployment artifact, and the notes, covered some architectures where, it's focused on training, and then others were looking at deployment. Now, Driverless AI can generate this thing called a mojo, right? And so some of the folks that maybe are newer to H2O, what is this mojo? So a mojo is a model object optimized binary representation of your pipeline, right? And so that pipeline includes two things. It includes the model and the feature engineering, right? And this is it's optimized for low latency scoring. And one of the nice things about this mojo and this artifact produced for driverless, it allows us to give us the ability to train once and run anywhere. So as we look at cloud, and so I want to deploy, within, a cloud's deployment infrastructure, you can take that mojo and deploy it there, such as something like SageMaker. Or you want to deploy within a database, whether it's, an online database, an open source database, or a Hadoop database. You can kind of use it to kind of score data there. Or maybe you want to start scoring out of your cloud, right? So maybe on-prem, or maybe take it to the edge. So you want to have this a portable artifact that can score wherever your application demands for, right? So that's the cloud or on-prem. And depending on the infrastructure, you can have flexibility to run this in Java, Python, R, and C++, right? And you can this facilitates both batch scoring and real-time scoring. And the other nice point here is it's algorithm dependent, right? So it's independent of XGBoost, or LogicVM, GLN, decision trees, TensorFlow, and et cetera, et cetera. You have one runtime that kind of supports all this model. So it really facilitates, makes it easy to deploy the model, and not just once, but as you kind of keep retraining the model, it makes it easy to kind of have that infrastructure to kind of push out new modules and new deployment pipelines. Next slide, please. So as we look at deployment, right, you can use H2O3 and Driverless AI to train models, and once you have a model, you can kind of you can choose to kind of use this mojo as your deployment ready artifact, and then you can kind of deploy into a REST server, into streaming services, into batch environments, and then you can have applications that can consume that data, from a server-oriented application to an edge-oriented application. And then, as more data comes in, we can kind of loop through and kind of go through the process of retraining and have that, leverage that deployment-ready artifact to streamline the process to redeploy new models. Next slide, please. But let me hand it over to you, to talk about some customer cloud use cases.
Yep. Thank you, Rafael. So, one of the customers, who's been completely on the cloud for us is G5. They've been in past webinars with us, but essentially what they do is they are a real estate sort of marketing firm. They essentially help find leads for their real estate managers and properties that they under management. They have, I think, over a third of all the senior living facilities in the country and a lot of other facilities as well. So as calls come in, they're qualifying them and then passing them to the right agent or the realtor property so that they can go and track those users, right? So the benefit for the users is to ensure that as leads come in, they are qualified and done properly. So what they are doing is essentially doing an intelligent lead scoring model where as soon as a call comes in from a location, let's say, they are able to then quickly identify whether the call is hot or warm or cool. And based on the rating, send it to the appropriate agent with the marking that this is qualified or not. And then on the flip side, they're also using this to identify, hey, which channel gives us the most hottest leads, whether advertising through Google or through Facebook versus general display ads. What is the most effective one for getting the best lead? And using that information to optimize the marketing campaign. So it's a two-pronged approach using the lead scoring for both of them. And to do that, they built a really nice pipeline completely on AWS, right? So what they did is as calls are coming in, they run them through sort of speech-to-text translator, but it takes the voice transcript, the voice call, audio recording, and converts it into a speech transcript. And then pass that to a word-to-vec model in H2O open source to create meta features. And then these features, along with the text, are passed to Driverless AI, which is running on EC2 to build models. And these models are then used to generate new features, and all of these are then built into the call scoring model, right? So essentially, they have a Lambda application that first takes H2O open source features for feature generation word-to-vec, and then the Driverless AI features combines them all into one big model that is deployed into production, again with Lambda. So you can see the entire pipeline is fully automated and running on AWS native services as much as possible, fully automated and cloud native. And by doing this, essentially, if you, again, just to think about what I described earlier, so using AWS transcribe first to convert the text, the audio calls, MP3 files into text, and then vectorizing them and using it through sending it to the scoring model along with additional metadata to generate a call score. So this is your AWS step function that is deployed for production, right? So this whole training, that was a training setup in the previous slide, this is the scoring setup, and that thing built completely end-to-end modeling and training workflow. And essentially what they got is they were able to build this entire thing with just 2 folks from the team. In a matter of a couple of months, they built this entire pipeline, going from training to deployment, all with Darla Theory and AWS native cloud services. And essentially they were able to score nearly 50,000 hours of calls with this, right? And previously they had human staff just listening to the call and recording and identifying the hot calls as cold. Now they have a model doing it. Essentially that leads to $1 million plus savings per month in just the personal cost. And then their scoring time, of course, is reduced by 95% because of the step function that I mentioned, right? The entire deployment cycle. And all this leads to a 5x faster model building and better accuracy in the wholesale side, which leads to better results as well overall. So it's a great example of what a small team can achieve. This is one of the sort of the success stories that if you go to cloud, you can do a lot of things without having a large workforce to support data engineering, DevOps, and modeling. Yeah, and so some of the things that this is finally, right, if you're a new cloud user, some of the things to think about is start with smaller instances, apply some auto shutdown, then you can do this with things like Puddle, which is our managed service, cloud service allows you to do that. Also minimize orphan instances, make sure you have a good admin tool so that you can look at the resources and the data, ensuring having good security practices, meaning, establish a good VPC, do not open all the ports, only open the ports that you need to for the softwares to be used. Having a good sense of the cost estimates is important too, because we do have it's a real phenomenon, runaway cloud costs. Some customers often, without thinking, without being aware of it, sometimes leave expensive GPU instances on, and suddenly they are slapped with a big fee. So having understanding of what the cloud costs are going to be is important when you're starting these instances. On a per hour basis, some of these cloud instances may seem cheap, but they can quickly add up. And of course, thinking about portability between cloud and on-prem is important, right? So understand how do you do that going back and forth. With that, I'm going to jump for a second to show a demo of how our managed service on Puddle looks like. Okay. Rafael and Patrick, can you confirm you guys are able to see my Puddle screen?
Yep, I can see it.
Yes, we can see it.
Thank you. So this is enterprise Puddle, and we also have public Puddle. But when you come in, this is running on our instance. But for our customers, we can make this run on their VPC. So in AWS or Azure, you can run Puddle inside, and you still get a portal like this. So your data scientists can log in through this portal and use their OpenID Connect or whatever the authentication mechanism. In this case, we are using internally Okta and OpenID. But this can be LDAP or Active Directory or whatever it is. And once inside Puddle, you can see you have the ability to launch a driverless or an H2O instance. You can also see how many compute units are available. So this is based on how much you purchase. On the admin side, as a user, as an administrator, you can obviously set up the different systems and experiments and users. So for example, let's look at the system types, right? So as an admin, you can control what system types are available for your end user. So we, for example, have 4 types of systems. One is the 2 M5 instances, M5 2X large and M5 4X large on the CPU for the CPU machines, and then P3 2X and P3 8X for the GPU instances. And you can see the per hour cost for those. But you can basically choose what you want available for your customer, right? And that's the real value proposition. So you can control the cost, but also give them the flexibility. You can also set up, of course, the system types. You can see all the different systems that are running. You can see what is running at any point of time, and can control as an admin shut down or stop those instances as well. Okay. You can see all the images that are available. So this is how you can control the versions. So like for example, we support 184 and 195, the 2 different versions for driverless, and then 3.28.1.1 for H2O. But you can very easily have multiple versions of the software available. So users can use the stable version, but also try out the latest versions if they want to try something new. Okay. We go back to systems. So if I want to create a new driverless instance, all I have to do is click on this. And as a user, I will just see the versions that are available. So let me pick the version. I can give it a demo DAI instance. Yeah, and then specify the instance type I want to start this on. Pick the disk size. Again, this is all pre-configured. And this is a really nice feature. You can specify what's the idle time before the instance is sort of stopped, right? What it does is freezes the instance, saves all the data, so you can come back and restart it again, but you don't get charged the cloud cost. And you can obviously pick it from 30 minutes to 4 hours or never. Of course, this is not recommended, but the default is set to 1 hour, let's say. And then you can specify what department you belong to so that you can get reporting at the end, which can tell you how much resources are consumed by different users across the different departments. Yeah. Leave it blank, and all I have to do is and what this is going to now do is in AWS, it's going to provision an instance. And once the instance is provisioned, I can actually go and look at the instance information and start playing with it. And let me just show you, pick an instance we ran earlier just to show what that looks like. So I have a demo instance, for example, right? So this is the instance, for example, once it's running, you can see which department was running, how much cost was run, and how long it was run. Right? And of course, I can scale up or scale down the system. So that's a nice feature. So let's say if I want to come back again, restart it. The next time I grew, I can say, hey, I want to run this now on a GPU instance because I'm going to run some more workloads. You can do that very easily. And all your data will be ported over. So that's a nice feature as well. In addition to that, we are also available on the marketplaces. So whether you're in AWS, Azure, or Google Cloud, you can take the driverless AI is available as a AMI or the equivalent image in the different marketplaces. You can use them directly. H2O is also available in all the different marketplaces as well, so H2O open source instances can be launched. In addition, we can work with the native infrastructure like Sparkling Water on EMR or Sparkling Water on Azure Batch or HD Insight, or even Databricks. So we can run H2O Sparkling Water on Azure Databricks as well. Then similarly on the Google Cloud side, we can run on Dataproc. And these are the cloud instances. So that, I think we have come to, the demo was supposed to be here, but I already covered the demo. But yeah, that can come to the end. And you can, of course, if you want to learn more about how to get started, you can pick up some other solutions, take a trial, attend a webinar, or go to Meetup. Of course, the Meetups are going to be online for the foreseeable future. But follow us on LinkedIn or Twitter to learn more. Of course, you can reach out to us at any point if you want to try out and play with the products. Okay. So I guess we can take some questions at this point of time.
Great. Thank you, Vinod and Raphael. We'll try to get to as many questions as we can with time permitting. First question is, so roughly speaking, is Enterprise Steam for on-prem cloud environments and Enterprise Puddle for public cloud environments?
Enterprise Puddle is definitely for the public cloud environment. Enterprise Steam is primarily used on it runs on basically in Hadoop based, it needs Hadoop or Yarn to run. That could be cloud or on-prem. So of course, majority of customers are using it on-prem, but it can very easily run on the cloud. So the reference architecture I showed earlier about using it with EMR is being used by some of our customers. So you can use Steam to manage your EMR cluster or Dataproc, or directly manage your Cloudera infrastructure, Cloudera infrastructure.
Awesome. Great, thanks. So this next one is a little long. So is H2O AI a solution that provides AI capabilities that I, as a developer, can call through APIs? For example, let's say I'm developing a solution to highlight insights for sales managers. I would send data to H2O, and it would process the data I've sent through an API into the AI algorithms. And what is returned to me in my solution would be outcomes of AI that I can present in my solution.
A great question. So this kind of goes back to the previous slide I had about like training versus scoring, right? So you're looking at two parts. To do this, achieve this, yes, that objective would be doable from a scoring perspective, but to do the training, you'll have to set it up. Now, you can do this all programmatically as well. So you can just call the driverless API to say, to the Python API to say, launch a model, here's the data, and here's the training set. And once the model is built, you can take the scoring output to get the results, like you said. So you do set up in a two-pronged approach by first building the models, and then you can deploy it like the developer environment you talked about. So you'll have a model running which can be called with the data real time, and then the predictions are made, which can be then showed in the user application.
Great, great. I recall that H2O's machine learning platforms focus on GPU-accelerated machine learning algorithms other than neural networks. Can you integrate your own neural network models into, say, driverless AI? And can driverless AI help you with hyperparameter optimization?
Yeah, we have the ability to bring in pre-trained neural networks. If you have your own neural networks, you can bring it. In addition, we also have the ability to bring your own recipes, which allows you to bring in third-party models. You can, if you have like a PyTorch model or a TensorFlow neural net, you can just import it as a model into driverless AI, and driverless AI will use it as part of its morning workflow along with other things. And then finally, we also have published some examples of how you can bring in sort of like a pre-trained network, like a BERT model, for example, and then refit this or tune that on your own data. So you can do that as well. So yeah, very, very, very definitely possible to bring in third-party data, third-party models, and then retune them or refit them in driverless AI along with other things.
All right. Next question: how does driverless AI reduce overfitting?
Yeah, it's a great question, and I know in this time I'll take a couple of things and then point you to a lot of documentation. We have really some amazing blogs. So part of the work that we did as part of our the Grandmaster team that I talked about is they have a lot of expertise in making sure that you do robust modeling, right? So a lot of techniques within driverless AI, it uses a lot of really good validation techniques to avoid overfitting. So there's an entire blog post. We use a technique called reusable holdout sample that allows us to look at all the data, but also do it without overfitting. In addition, when we go through things like time series, these problems, we are very smart about ensuring that we do the correct kind of splits so that we don't feed it to the future. So I would say that the best way, and then in addition, we also give you warnings as a user, right? So when you launch a column with leaky, like a lot of data set, a problem with leaky columns, for example, if you have a variable or a column that is highly predictive of the future, but essentially it's not really predictive, it's basically a leakage, right? It is information you'll not have in the time of prediction. So it's a variable that should not be included ideally, but let's say you accidentally include it, we'll give you a warning. We'll say that, hey, these columns are highly correlated. Just check if these are overfitting or not, right? So there's a whole bunch of techniques we run, and these are, we run these checks in the model even before we get started. That's part of the nice things about driverless AI. It'll run these sort of data science pitfall checks for you and give you those warnings and then prevent them if we can. But then there's a whole blog around how do we do cross-validation to avoid overfitting.
Great, thank you, Vinod. Now, can H2O consider offering learning resources to wider public and extend the driverless AI license to all learners? What are the best means to get hands-on in learning H2O?
Yeah,
so I'll take that one.
Yeah, I mean, so we have a couple different things. So for if you're a student or a professor or a researcher, we have an academic program that supports you with all the different products and tools from H2O.ai. And for anyone who wants to get started, we have a whole learning path that allows you to get started actually in the cloud. So we have a free 2-hour test drive where we give you environments for driverless AI and H2O3, and actually you can use it for 2 hours at a time. So you can use it on multiple intervals. So here you're looking at a learning path and how to get started and set up, and this will get you set up with our sort of training and tutorial environment called Aquarium. And so you can get an Aquarium account, choose your environment, launch it in the cloud, and so you could probably get up and going between 6 to 10 minutes, and you'll have a working driverless AI environment or H2O3 environment, and then we give you a very prescriptive learning path to how to get started.
Great. I think that is the last question that we have. Oh, I'm sorry. I was just saying, I think that's the last question we have time for today. So I want to thank Raphael and Vinod for taking the time and doing a great presentation. I'd also like to thank everybody who joined us today for today's webinar. The presentation slides and the recording will be made available on our Bright Talk channel, and we hope you have a great rest of your day.
Thank you. Thank you, everyone.
Thank you. Have a good day.